Okay, so we're going to go over the Chapter 6 review questions in this video. So the first group of questions is about whether something is a binomial experiment or not. So 4 things have to hold true for something to be a binomial experiment, and they're in red above. So 1, you have to perform the trials a fixed number of times. Each trial has to be independent. There are only 2 outcomes, either success or failure. And the 4th thing is your probability of success has to be fixed. So in this first group here, we're going to determine if the following examples are binomial experiments and justify our response. So you draw a marble 500 times from a bag with 3 colors of marbles. The random variable represents the color of the marble that is drawn. So this one is not going to be a binomial experiment because there are more than 2 outcomes because you have 3 different colors of your marbles. So no, because there are more than 2 outcomes. For the next one, survey 500 college students to see whether they are enrolled as a new student. The random variable represents the number of students enrolled as new students. That one holds for all 4 criteria, so yes, that is going to be a binomial experiment. There is only 2 outcomes, you're either enrolled or you're not, and each trial is independent of each other. Again, one student being enrolled is in no way going to affect whether another student is enrolled or not. So yes, there are 2 outcomes, and each trial is independent. Okay, and you're doing it exactly 500 times. Okay, 2 more like that. Again, same type of question here. So the next question is testing a cough suppressant using 980 people to determine if it is effective. The random variable represents the number of people who find the cough suppressant to be effective. So this is another one that is a binomial experiment. Okay. There are only 2 outcomes. It's either going to be successful, the cough medicine is going to work, or it's not, and each trial is independent. Again, if it works for me, doesn't mean it's going to work for someone else. There are 2 outcomes, and each trial is independent. Okay, and the last one is selecting 5 cards one at a time without replacement. Those are the key words right there, without replacement from a standard deck of cards. The random variable is the number of picture cards that you obtain. Okay, this is not a binomial experiment because, again, if you draw 1 picture card and you have it in your grubby little paw, the next time you go to draw a picture card from that deck of cards, the probability of success has changed because you are holding one of those cards in your hand. So no, because the trials are not independent. Okay, or you could also say there, that's true, the trials are not independent because, again, if you draw a picture card, it's going to affect the probability of the next time you draw. But you could also say there that the probability of success is not fixed because once you draw one again, it's going to change that probability. And now we're going to move on to the binomial formula, the binomial probability formula, and binomial CDF and PDF in the calculator. Okay, so according to insurance records, a car with a certain protection system will be recovered 86% of the time. Find the probability that exactly 4 out of 7 stolen cars will be recovered. So the key thing here is exactly 4. So you want to find the probability of 4 and only 4. That's it. So 2 different things that you can do here. You can use the formula, the P of X equals N to the C, and choose X. P to the X power times 1 minus P to the N minus X power. Okay, and we're just going to have to do that one time because then this is an exact amount. So your probability of success here is going to be 0.86. Again, X is going to be 4, and your number of trials here is 7. So if we plug that into this formula, we're going to have 7 choose 4 times 0.86 to the 4th power times 1 minus p. Nope, sorry, p is 0.86. But I actually put that in there. 0.86 to the 7 minus 4 power. So again, you can chuck that all into the calculator at once, or again, we need to get back into the habit of doing either the binomial PDF or binomial CDF. And since this is an exact amount, this is when you'd use the binomial PDF. So to get to binomial PDF, remember you're hitting the second key and then vars. Okay, and then once you do that, scroll down, again, exact amount. That's like having a PDF version of a document. So you're going to do binomial PDF. Okay, and again, on the newer calculators, it's going to flat out ask you what X, what P, and what N are. If you have the older calculator, you're going to have to type it in a specific order. So the N has to come first, then your probability, and then your value of X. So that's what it should look like after you type it all in. And when you hit enter, again, 2 slightly different answers that you're going to get. As an exact answer over here, you're going to get 0.05253. And if you plug this one on the left-hand side, and you're going to get 0.0525. Okay, so you can see they're pretty darn close. So an exact amount, binomial PDF. Okay, this one is definitely going to be one where a calculator is definitely going to come into handy here. So we believe that 79% of the population of all Calculus 1 students considers calculus an exciting subject. Suppose we randomly and independently selected 26 students from the population. Find the probability of observing at least 15 students who consider calculus to be an exciting subject. So really what they're asking us here for is the probability that X is greater than or equal to 15. Okay, keeping in mind that we've selected 26 students. So if I wanted to do this by hand, I would have to find the probability of 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26, and then add them all together. Okay, it would take forever. So this is definitely when you're going to want to use the calculator. And again, binomial PDF is an exact amount, but when you're doing a binomial CDF, remember your calculator can only work in terms of less than or equal to. So now I need to change this into something that's going to be less than or equal to, so we'll do the complement. So what we're going to really find here is we're going to do 1 minus the probability that X is less than or equal to 14. So we'll get rid of everything 14 and under, and that will leave us with 15 and above. So this is a straight calculator question now. So again, our probability here is 0.79, our N is the 26, and X is 14. Again, that's coming from there in this one. So again, we're going to do the binomial CDF on the calculator. So again, you're doing second vars, and then scroll down till you see binomial CDF. So once you enter, I'm going to write it out the way it should be. Again, you can do the binomial CDF on its own inside the calculator. So binomial CDF. Again, once you type it in the calculator, especially if you have the older calculator, the order matters. So it has to go 26, 0.79, and 14. Okay, so again, I would do the binomial CDF first on its own and then worry about the 1 minus. When you do that binomial CDF in the calculator, you should come up with an answer of 0.0036. So then when you do 1 minus that, your final answer here is going to be 0.9964. So that's your probability that at least 15 students think that calculus is exciting. Okay, next one. According to the government data, the probability that an adult was never in a museum is 15%. In a random survey of 20 adults, what is the probability that at most 4 were never in a museum? Okay, so we want at most 4. So that would mean that we want 4, 3, 2, or 1. So we're going to do, again, binomial. That's going to be, it's not an exact amount. It's going to be a less than or equal to. Let me write what it is. It's going to be the probability that X is less than or equal to 4. Okay, so we're going to do binomial CDF again. Let's get all of our P's and X's and N's. So your probability is going to be 0.15, your N is 20, and X again will be 4. Again, this isn't the complement because we are starting out with less than, so we don't have to worry about doing 1 minus. So we're just doing the second vars and scroll down to binomial CDF. And again, that 20 has to come first, then the probability, then X. And when you chuck that into the calculator and hit enter, you should get an answer of 0.8298. So again, you could have figured out 4 different probabilities. You could have figured out the exact probability of 4, 3, 2, 1, and 0, and then added them all together, and it would have given you the same thing. It's just going to take you a lot longer to get there. Okay, and this one we have 65% of men consider themselves knowledgeable soccer fans. If 15 men are randomly selected, find the probability that between 6 and 8 inclusive of them will consider themselves knowledgeable soccer fans. So this one, because you're doing between 2 numbers, you cannot do the binomial CDF or the binomial PDF. Actually, I mean, you can do the binomial PDF, but you're going to have to do it 3 separate times. So we're going to have to somehow individually find the probability of 6, find the probability of 7, and find the probability of 8. So we want the probability of 6 plus the probability of 7 plus the probability of 8. So again, you can find the probability of 6, 7, and 8 however you see fit. Again, you can use that binomial formula, or you can just do the binomial PDF 3 times. Again, 3 times for 3 exact amounts. I think it's easier to do the binomial PDF only because when you go into the calculator, you just have to change the one number very easily. Okay, so we're going into the calculator, and again, we're doing it 3 separate times. We're doing it once for 6, once for 7, and once for 8. So again, I'll write the first one that you're going to do. Binomial PDF. N has to come first. So your N here is going to be 15. Next thing is going to be your percent. So our percent here is going to be 0.65. And our X in this case is going to be 6. So the only thing that you have to change each time you go in is going to be that number. So the next time around, you'll change it to a 7, then you'll change it to an 8. So when you do the probability of 6, that should come out to 0.0298. Probability of 7 is 0.0710. And your probability of 8 is 0.1319. Okay, and again, last thing that we're going to do is add straight down there. And when you do that, you should get 0.2327. Okay, again, you could have used the binomial and choose x times p to the x power times 1 minus p to the n minus x power. You could have done that 3 separate times and figured it out that way as well. However you're comfortable doing it. Again, these 2 things are interchangeable. Again, I think it's just easier to do the PDF just because it's less time. Okay, and then this is the last question from chapter 6, and then I will make another video for chapter 7 eventually. Okay, so a quiz consists of 770 true-false questions. If the student guesses on each question, what is the mean and the standard deviation of correct answers? Round your response to the nearest hundredth. So you don't have a list of numbers here. We can't put it into L1 and do that stat calculate. So we have to come up with a different option here. And again, this is when you're going to use those 2 small little formulas. Your mean is going to be n times p, and your standard deviation is the square root of n times p times 1 minus p. Okay, so the only thing that we need to know here is what n and p are. If it's a true-false question, your probability that you're going to get it correct is 50%. So that's going to be 0.5 or 0.50, doesn't matter. And our n here is the number of questions that there are, which is going to be 770. So our mean is going to be 770 times 0.5, which will give you an answer of 385 Again, just because I wrote that in shorthand, I'm going to tell you that that's the mean again. And then this one is going to be our standard deviation here. We'll have 770 times 0.5 times 1 minus 0.5. And when you stuck all that into the calculator and round to the nearest hundredth, that should come out to 13.87. And that is your standard deviation. And that's it.